Good everything.
Hi, I'm Thomas, a full-stack web developer, and in this series of videos, I'm going to be showing you how to implement Docker into your development workflow. Docker has many uses, but for the purpose of this tutorial, I'm going to be showing you how to host your local files on a Linux virtual machine. This means no more headaches when you're trying to transfer your project from Windows to Linux. You'll be able to develop with your destination platform as a first-class citizen. Let's get started. In order to install Docker, you're going to need to go to docker.com. You're going to click on Get Started. So it's going to take you to Docker for Windows, and you're going to need Microsoft Windows 10 Professional or Enterprise 64-bit. You're also going to need a Intel CPU that supports virtualization. So you're going to have to do some research and figure out if your CPU supports virtualization, and more specifically, if it supports Hyper-V. So you're going to download and get on to installing Docker. So the install process is actually fairly simple. You just click install, go through the prompts, and there you go. It should finish relatively quickly. Now I'm going to go over some more advanced things that Docker does, so you can get a general grasp of what it's used for. The number one benefit of using Docker is the fact that you can easily configure environments and share them on any platform. Now, environments don't just have to be like Node or Python or Ubuntu, just something simple. What Docker specializes in is actually massive horizontal scaling. Each environment can be composed of many different containers, and each container would be, say, a Node.js instance, or a Postgres database, or a Redis store, or an Nginx front. And as your system requires more and more resources, Docker will spawn instances of what it needs in order to provide the resources necessary. That's all I'm going to say about this for now, but if you are interested in seeing what Docker is capable of, I highly recommend you checking out their site and looking through it. So now that Docker has finished installing, we're just going to launch Docker. If you happen to be running Docker on a virtual machine, like I'm doing here, so now Docker is up and running. Here you see your little prompt. It's going to ask you to test some of the commands and do whatever you want to do. So if you want to follow the prompt and do some of this, you can, but I'm just going to skip past that. We're just going to open up Windows PowerShell. We're going to do a simple hello world. So with Docker, let's just quickly check the version. So docker-v, and there you go. We get our version. Mine's 1.13. You might be on a newer build. It's actually very simple. We just type docker run hello-world. Now Docker is going to automatically detect that you don't have the hello world image on your computer, unless you do for some odd reason. But if you don't have an image, Docker will automatically download it. And voila, there we go. It's already done. Hello from Docker. This message shows that your application appears to be working correctly. And that's all you need to do in order to run hello world. Okay, so now we're going to do something a little bit more crazy, which is getting bash running in right here on the Windows PowerShell terminal. And in order to do that, we're going to enter the same command, docker run, but pass it an IT argument, so -it, and then you're going to write Ubuntu, which I'm horrible at doing apparently. But I'm going to show you exactly what IT is before we run that. So you're going to do --help in order to get a list of all the possible arguments. And here -i, which is interactive, so it's going to open an interactive shell. And then T, which is going to make a sudo terminal, which is basically like when you SSH into a server or something. So in order to do this, now we're just going to do docker run -it ubuntu, and it's going to automatically install the Ubuntu container, which is not an exact replica of what would normally ship with Ubuntu. Like, you're not going to get Vim and like the nanotext editor, because these are scaled down, very small, so they're performant and all that, like not going to waste a lot of space on your machine. As you can see, it's only 50 megabytes, which Ubuntu's pretty small already as is compared to at least Windows, but 50 megabytes is just ludicrously tiny. Okay, so now we are in the shell. We are in Ubuntu. So in order to prove that, you could just type ls, which is going to list all the items in your working directory, and voila, everything you would expect from an Ubuntu install. Okay, so now let me go over some of the things that are, quality of life and things you need to know for the shell when you're running Docker with Ubuntu. So when you create a container, you're going to want to give it a name. In order to do so, you just do -- name and then pass in whatever name you want. In most cases, you're going to want to give your container a name about what it does or what it hosts. And voila, we're in the shell. So the reason for naming this is because in order to exit the shell, you have two options. Control PQ, which will return you to where you are, but continue to run the Ubuntu image. And so you can type docker ps to view your available containers, and here we have the container ID, the image, command created, and then the name right here, which is James. And in order to get back into our Ubuntu container, our Ubuntu shell, we just write docker attach James. You can also enter the container ID. Now see here how it looks like it's paused? It's just because you have to add some kind of input in order for it to register. I don't know why it does that, but it's just a tiny bug that they still haven't got around to fixing. Now another way to exit is to literally just type exit in the shell, which is going to close the container. The container will not be running anymore. So if we write docker ps, you can see that it's missing. It's not there. Now another thing you can do is docker images, which is going to show you all your downloaded images. And as you can see here, we have Ubuntu in a hello world. Right now, we don't need hello world. So you can type docker remove I, like RMI, which is remove image. And we just type hello-world. Now, if it doesn't work, you just do remove. And you pass it a force variable. Okay. And voila, it's gone. So now we write docker images, and all we have is Ubuntu now. So let's clear the screen and show you one last thing. So say I have my Docker shell, and I use Control PQ in order to exit it, and I still have my shell open. My container is still running. Say I want to remove it without entering it, I would just run docker rm-f, the force variable, to make sure, gets rid of it. And then Docker assigns random names if you don't name your container. So this one's called Clever Shannon. So let's just remove Clever Shannon. And there we go. And now if we run docker ps, no more Clever Shannon. Okay, so now that we have a basic grasp on how to use Docker and what it does, let's move on to implementing it into our development workflow, because that's the fastest way to learn. So I've gone ahead and created a GitHub repository here with some little stuff. All it does is just a simple Node.js application that prints the Node environment. And it prints the environment that the file is being served from. So if it's running on Linux, it's going to print Linux. If it's running on Windows, it's going to print Win. If it's running on Mac, it's going to print some crazy stuff. So let me put the URL down here at the bottom, and let me copy this. And we're just going to do a git clone. Well, guess we'll clone it into HS. And there we go. Now we're going to navigate to Docker Hub. So hub.docker.com. And we're going to look up the node package, because this is a node file. This is a node application that we're going to be serving. We go to the node package. We scroll down until we come to here. And we're going to create our own Docker file. So I'm going to open up Sublime Text. And I'm going to mash these two to the sides. We're going to copy right here what they have. I'm going to paste it here. Let's remove this. So we have from node. So what from means in a Docker file is what is it going to base itself off of? What image is it going to use to create itself? Say I wanted to create an Ubuntu application, I would be replacing this with Ubuntu. Now Node actually has its own from Ubuntu, like it's on an Ubuntu server itself. And then we have expose here, which is going to expose the port that our application is running on. Now the application I have made is running on port 80. I chose port 80 because that's the standard port when it comes to hosting a website off of a server. And you're not able to do it on your host PC typically because it's a protected port. Now I'm going to save this Docker file into the directory that I cloned my repo into. Now this is very important. You need to make sure it's called .docker file, same casing, because this is the file that Docker will be looking for. And this is literally the file type, is Docker file. So you save, and there we go. We have it finished. Now we're done with this. We move over here back into our terminal. And let's put this to the side actually. Now let's get around to actually building our application. So let's cd into our repo, and let's quickly just open that up for me to explain. We need to have our application, our Docker file in here and the application together, because it's going to build this application in this repo. It's going to be looking for it relative to its position. So it has to be in here. And they provide us with the command to build our application. So let's copy paste that. Now docker build -t. Now -t means tag. It's what you're going to be naming your image. So in my case, I'm going to be naming this hello system. And then this dot here, which is, you know, the relative file path. So this is where it's going to be searching to build the application. And in my case, this does not work. So I have to add another argument, which is -f. So file. This is I'm gonna be telling it what file to look for. So in my case, it's going to be looking for a .docker file. And then we have to put in, of course, the relative path again. And now it will start building. Now I have no idea why it does this on my machine. Of course, I am running this all off of a virtual machine. So there's a lot of problems here. But, you know, you gotta learn to adapt. Okay, so our build is finished, and now we can move on to the next step, which is actually running our application. So they provide us with the command to do so, and don't worry, I'll go through what each of these arguments mean. And here we are. So basically what this is going to do is it's going to run the application, and it's going to do the -it just like you would run with the Ubuntu, because it is Ubuntu. And so -i interactive -t pty, a pseudo terminal, --rm. Now, what this does is every time you start the app, it's going to start fresh. It's going to delete everything it had before and basically just boot from what it came with. And then here, --name we've already gone through, which is my running app, and then my node.js-app. And we can just run this now. But, of course, we have to replace that with our image name, which is hello system. And voila! Here we are, it's running. So in order to access this, we're actually not going to be able to get to this through our local host right now. If I go to localhost 80, of course, it's not going to work. If we want to access our application that's being served on the container's port, in this case it's 80, and bind it to whatever port we want on our local machine, we're going to actually have to add a port command. So let's just do that real quick. So -p, and then our port. This is the port that we're going to bind it to. So in my case, you know, let's just go a little crazy here with 1337. And then add in the container's port. This is what the application is being served on. So in our case, it's port 80. And then we can just pass it a name. So let's call it hi, and then pass it the image. Hello system. It's going to run. Here we are. And we come here to localhost. And it's going to greet us with Hello Linux, which is what it's being served off of. Now, say we want to make some changes to the file. And let's just go ahead and do that real quick. Let me show you the problem with actually changing the file right now, and that it's not going to work. So let's go in here, let's edit this, and here we have hello, and let's just change this to hello there, buddy. And then it's going to say whatever. And that's now changed, but the problem is, even if we run the same command, now if you run into this error, you actually have to remove the, you have to remove the container, even if it's stopped. Like, it won't show up here in Docker PS, but it still exists. like I can actually just run docker start, and I believe I can just leave out all of the arguments. I can just run docker start hi, and it should just start whatever I had. And it's actually going to start it in a detached mode. If I wanted to start it attached, I would of course pass the IT parameter, but in this case, it's detached. Here we are. We can just come over here, and it's running right now. As you can see, it's running. And if I wanted to get back into that, I could just docker attach myself to hi. And here we are, we're in it. It doesn't show anything, of course, nothing is being logged to the console, so let's just cancel it, close it. And now, in order to remove this from it, we're just going to have to do exactly as I've shown previously, which is docker remove -force hi, and remove it from the system. Now we are able to re-execute the command, and the changes you're going to see have not been made. The changes aren't here. So in order to get these changes pushed to our application, we're actually going to have to sync like our file system to the containers file system. Now, we could just constantly rebuild the application every time we made a change, but that is a hassle, and that takes a lot of time. So to avoid said hassle, we're just going to bind our file system to the Linux file system. In order to do that, you're actually going to have to come down here to the little whale, go to settings, go to shared drives, and select your drive that you're serving the application. Whatever file you want to bind, you have to, whatever drive it's on, you have to share it. So now we just run docker run it -p 133780, and just to show that I can make this port whatever I want, let's change it back to 3000 here, and then -v. Now on Windows, you can't do this, okay? You can't name your file system like that, like a C or something. You have to do it this way, the Linux way. So you would do --c/ users/ whatever you are, wherever the file is. In this case for me, it's in the HS folder. And then we're going to bind this to, in this case on the node thing, it's going to bind your app, like your app is going to be located at user/source/app. And then let's give it the name again. So name hi, and then hello-system. Here we are. It's not serving on 1337 anymore. And voila, there are our changes. Now this can actually be done live. Anything with images, anything that doesn't have to be recompiled by Node every time you do it, like static images or like pug template files, like HTML files that, you know, services and stuff. It could just be done live. You can just change it, keep the thing running, and you don't have to restart it every time you edit the files. In this case, though, because the server's running on this, I have to restart it every time I make a change. Now I'm going to show you how I use Docker to support my development workflow. So here we have my portfolio websites directory. And here's the Docker file, exactly the same from the previous parts of the tutorial. Now, in order to actually start working with Docker, of course you need to run it, so Docker, and I'm going to check my images to see what I've got. Here you see I have my portfolio, so I just do docker run -it portfolio, but let's not forget we need to include our P, so in this case 3080, because it's being, my application is being served on port 80. Let me just show that right here, port 80. We also need to sync up the libraries. And there we go, libraries. Now all we need to do is run this. And there we are. My website is running. So let's take a look. And voila, my website is currently being hosted on Docker. So now let's just show a little bit of that live file changing that I mentioned. So in that case, if I go over here to my views and then into my index, because the directories are synced using Docker volumes, I can just do whatever I want here. Say I want to add an h1, so this is using the pug templating engine, so h1 docker is here. Save. And now all I need to do is refresh. And there it is. Pretty cool, right? So that's the basics of what you need to get started with implementing Docker into your development workflow. My name is Thomas, and it's been a pleasure. Thanks for watching.
Hey guys, thanks for watching the video. If you're interested in coding bootcamp, check out devmountain.com, where housing is included in your price of tuition. And don't forget to like, comment, subscribe, and share, and support me on Patreon. I'll see you guys in the next video. Thanks for watching.